Welcome back. Welcome back. We're going to start the second panel. So if those of you could find your seats, that would be terrific. I think the first panel really started us off on the right track. We were re-engaged and re-empowered to think about the engineering mindset that we're developing in our students and to ensure that that mindset has engineering ethics front and center. What it also hopefully reminded us of is that we must have the faculty involved in engaging and helping those students to develop that mindset. And so this session is devoted to ideas related to supporting and encouraging and helping faculty to basically be able to bring that enthusiasm, those lessons, that learning into the classroom. We have 4 speakers again. The speakers know that their constraints are to try to keep their material within 10 minutes. We're going to go through each of the speakers. I'm actually going to avoid having questions right after the speakers so that we could have even more time at the end for a more engaged discussion. In terms of the speakers, just quick introductions. Larry and Tom are going to present this perspective on supporting faculty more at the micro level in terms of their institutions. And then we'll go to Anne and to Jamie, who are going to present more models at the macro level of how to create change within the institution, within the department, within the program. And so with that brief introduction, I'm going to turn it over to Larry.
Okay, thank you. Actually, Nike tells us what to do. Just do it. All right, now I'm assuming this is going to work. Okay, so the reality is I think ethics is really going to take off based upon where ABET is going. We've seen it in other areas, and if you're not familiar with it, ABET is going to move from what it currently has to something like a proposed criteria 3 that I have up there. And if you parse what they're saying, that what this implies is that students now would have to acquire certain 3 skills. They have to be able to recognize a potential ethical dilemma. And then they need to be able to make informed engineering judgments about how you're going to deal and resolve that dilemma. And not only that, you have to consider the long-term consequences of your actions, and basically in a societal context. Now, if they can pull that off, we're in great shape. It's certainly something that we've tried to do at the Swanson School of Engineering, and I'll show you a little bit about where we're going and what we've done. Basically, my interest, my concern is that these things are gray areas that they're going to be dealing with. Are the students able, when they get into the workplace, because they will all have to confront this if you're going to work as a professional engineer. It may not be at a high level, but you're going to have to confront that gray issue of you are going down the slippery slope of a potential ethical dilemma with serious consequences. And you've got to be able to evaluate the risk of doing that. When we created our course a number of years ago, we called it Balancing Cost, Schedule, and Risk. Why is that? Because when cost pressures and schedule pressures go up, so does risk. And engineering students need to be able to evaluate risk and communicate that to people. So we also want them to be able to resolve the situation without becoming a whistleblower. We don't want to educate whistleblowers. We want to educate engineers that can recognize they're in a gray area, they can assess what the risk is, and they can be able to work their way out of the particular situation and ideally have a win-win situation. How to achieve this? You're going to hear a number of different ways. My own feeling, and I think it's worked, is a lot of cases, classical cases, and things in the newspaper. I made my students once a week bring an article in from the New York Times, Washington Post, some other reputable publication that talks about a ethical dilemma, ideally an engineering ethical dilemma. It's amazing what you can find in 1 week. And then, of course, you get a number of other things, gifts that are given to you, from a problem in the Gulf of Mexico with a drilling platform to the Flint water situation. By the way, you don't recognize that. That's one of the pipes in Flint. So I want them to read these cases. I want them to watch things. I want them to review. And then I want them to come to class and discuss. Our classroom is a circle, because in a circle you can really carry out a discussion. I want them to reflect on it written. I want them to discuss it again, and I want them to reflect some more. And eventually, I think they'll get it. Now, there are a number of alternatives to doing this. Some people focus on seminars and guest speakers, proposing problems. We've already heard about that. We had a fairly large NSF grant a few years ago on model eliciting activities. These were creating realistic problems where there was a client. It was set off with a memo solved by a team. They had to come up with a general model and then solve the specific case. We thought, why not put an ethical dilemma into the middle of these model eliciting activities, which is what we did. So when somebody was doing an analysis that required them to see whether it was a make of tires or a make of SUVs that were causing problems, that once they came up with the statistical model and the solutions, then they were also told, by the way, the client does not want you to reveal this information to anybody. What do you do with that? Do you follow the client when you know people are being killed? Or do you reveal that and then discuss it? And these can go into courses. I'll show you what we did to do that. You know, certainly modules in courses, you're going to hear a lot about modules, and there are some good things. For a philosophy course or an engineering ethics course, which is the way that we're going. What are the barriers? You probably know this, but certainly finding competent, qualified instructors. Pedagogy, how are you going to do it? You know, we favor a lot of discussion. I had a colleague from Japan come over. He teaches ethics to 1,500 students a year. He's got a team of 10 or 12 faculty that do this. And he wanted to see how we did it. He went to 2 of our classes, came back and said, there's no way we can do this. Japanese students will not discuss and argue in the class. So pedagogy is important. Class size, we're now running into, when you've got a class of 60 or 70, how do you have the discussions that you would have in a class of 15 or 20? How do you ramp it up? And what that requires is clever use of TAs. Certainly faculty and administrator buy-in. My feeling is the problem is not the deans, the problem more is at the department chair level, because at the department chair level, that's the person that has to make the decision as to how you're going to pay for the course, who's going to teach it, what are you going to give up, and how do I deal with the faculty that are complaining about doing this. So, you know, my feeling is if and when, because I think it's when, ABET makes ethics more important, the deans are going to be on board, and the trick is going to be how do the departments do this? And assessment. How far can you move the needle? We've done a lot of assessment. We can tell you that moving the needle is tough, but you can make some progress. So what do? As I said, we've created an elective course balancing cost, schedule, and risk. Our bioengineering department has a great course on societal, political, and ethical issues in biotechnology. If you look in the book of 25 exemplary programs, the graduate version of that course, my colleague Rose Pincus has written up, which she's done. And the trick is to take students that have gone through the graduate course and they become the TAs for the undergraduate. Chemical engineering has a course on safety and ethics. And there are various courses where we've gotten our EMEAs and other realistic posed problems into them, and obviously capstone design. So I think all of that can be good. I put bad philosophy, core introduction to ethics from philosophy, and that's only if that's the only course. If the only course your engineers are going to take is an introduction to philosophy course, and you say they are now ethical engineers, you're kidding yourself. And then ugly, the worst is the ones that simply go into an undergraduate seminar, they bring somebody in from the outside to do 1 hour, and now they're students, and then they might survey them because they need to show ABET something. How much did you get out of this? That doesn't work. Relative to assessment, we've done a number of things. Basically, we've developed rubrics, 5 factors, and there are other ways of doing it. Has the student, to what extent, and you use the rubrics on cases that the students have written up, to the extent that they recognize the dilemma, were they able to see what it was? What did they do about information? How did they analyze the case? And did they take multiple perspectives? Did they look at everybody's perspectives? And finally, what was their resolution? How was that? And we've shown these can work. We actually have for the 5 areas, 5 levels, but in a relatively short presentation like this, and you couldn't read anything if I had the slide with everything on it. But the rubrics work. They do take a lot of time. It takes time. Perfect. So what I want to do, and Sharon, I had this in, and then I cut it out, and then Sharon suggested I put it back in. How do I know this works? Well, this is an email I got from a student who took the course 7 years earlier. And it basically said, I wanted to send you this brief email, thank you, and that I appreciate everything that came out of my 1 semester course with you as an undergraduate PIT during the class Cost, Schedule, and Risk, Engineering Ethics. I just had this moment of realization as I was updating my to-do list at work, which included the following items: a request for me to do a cost breakdown so a more granular review of this proposal's costs can be performed to see where costs can be reduced, a request to update the risk registrar and review if items can be removed or decreased, and lastly, a request to meet with the proposal scheduler to see where efficiencies can be gained to reduce the schedule or get this subsystem off the critical path. As I was writing out this list and realized how the 3 tasks are at odds with one another and wondering how this wasn't being understood or understood and ignored, I remember sitting in that class with you and talking over these issues repeatedly and reviewing case studies. That course was one of the better experiences I had during my curriculum, and one that I feel I continue to get more from as I move along my career. So certainly an example of retaining things, because this is 6 years, 7 years after he had the course.
Thank you, Larry. And now, after those examples that are specific to Pitt, Tom's going to give us some ideas of how, at Penn State, they've put in programs to help faculty be able to do some of these things. So, Tom?
Are my slides somewhere? I can finish with this one, but I'd rather not. I hate this case. There we go. Yeah. So thank you. I'm happy to share with you a little bit about what we're doing at Penn State and have been actually doing the stuff I'll talk with you about for 15 years. It's part of what we are doing at Penn State. There are other stuff we're up to, and we'll be happy to share that. I'm speaking to you today in my second role, which is director of the Education Center. We have an endowed center at Penn State in the College of Engineering that was started in 1990 by an alumnus who was worried about global competitiveness. So the approach that we take in supporting faculty to teach engineering ethics was really designed to address two main issues. Most engineering faculty members feel like they don't have the core competencies to teach this stuff. They just don't know it. Maybe we had one philosophy course. And then the teaching and assessment methods used in engineering ethics education are typically not the kind of stuff that we do naturally in engineering. We're doing technical stuff, solving problems with our students. Our approach to dealing with these two issues then was to work with colleagues in the Rock Ethics Institute. It is a similarly well-endowed ethics institute in the College of Liberal Arts to develop a workshop to address these issues. And the team that developed this workshop at first one was in 2002, and it was interdisciplinary. And I think that was one of the really critical parts of making this work. And the way this happened, and I don't mean to make you all say, why doesn't this happen at our place? We had a third alumnus give us money to specifically connect the Ethics Institute and the Leonard Center around ethics education, because this happened right around this time of EC 2000. So Nancy Tawana just stepped down as director of the Rock Ethics Institute. She and I got joined together by our associate deans and came up with this plan for the workshop. So John Chrisman, her colleague, was the lead in doing the ethics instruction in this workshop. Andy Lau and I were kind of the color commentators. We were the engineers connecting these things. And our colleague John Wise, who was at the time director of engineering instructional support, talked with the faculty about appropriate design methods in engineering education. So the workshop, and I want to point to the footnote, which I couldn't figure out quite where to bury. We didn't invent this workshop. Michael Davis was doing workshops like this at IIT in the 90s, and we adapted his model that was funded by NSF to our local context. It's a week-long commitment of our faculty, and I'll show you the line at the bottom. I wanted full disclosure. We are able to pay faculty for a full week of their summer salary. It's not a nominal $1,000. If you make $3,000 a week, that's what we pay you. Again, what Mr. Leonard did for us is mind-boggling. So here's how it works. So the first part of the workshop, we come together for 2 days. Faculty members get a primer in ethics theory and frameworks from an expert in that area. We do application to cases. We usually start with an academic integrity case because we want to meet students where they are. Let them see ethics in their context, and then we start talking about professional cases. We also want faculty to see how you do instruction with cases because we don't typically do it. And I have to tell you, John Chrisman was the master. It was just amazing to watch this colleague facilitate grumpy engineering faculty members who didn't really want to do this stuff. I mean, it was wonderful to watch us because we really were simulating our students in some ways, and we didn't intend to, but we were, right? So John was a master and really showed us how to do this. We provide resources. The first time we did this, we had a grad student go out, pull cases off the web, categorize them as, are they a dilemma? That is, are they relatively simple, sort of black-white two-issue case all the way to real cases by discipline. It was an amazing website. It's now so out of date, it's gone, unfortunately. But we tried to help the faculty do that. We gave them resources on assessment methods, which is something we don't know how to do. How do you assess the logic of an argument as an engineering faculty member? I don't know, right? So our colleagues from philosophy helped us with that too. And then John Wise talked to us about appropriate instructional design. It was pretty new to engineering then. It was a few years into EC 2000, so learning objectives. Think about your assessments, do your methods. So then after that 2-day workshop, faculty members go off on their own and design activities for their own courses. That's one of the commitments. If you're going to take a week of summer salary, you're going to do this. So they go off, they design stuff, they come back at the end of summer, typically in August, and we get together in groups. If the group is large enough, we break it in 2 pieces. they present, don't actually run through, but they present their materials, get feedback from the philosophy experts, from people like me and Andy who are experienced in doing this. Then they go off and implement it, and typically we'll get everybody together in the spring just to talk it through. How did it go? And it's worked out very well. So over the last 15 years, we've offered 3 versions of this workshop, and there are subsets of these. We've done them on ethics and leadership, ethics and entrepreneurship at the undergraduate level, but primarily, until about 2 years ago, we focused on undergraduate engineering, capstone, and other courses. Very recently, within the last 2 years, we opened up the scope of the Leonard Center's work to consider also graduate education. So we now do work on graduate education. And it's a new team. My colleagues, Eduardo Mendieta and Denver Tong, who you saw, were the ethics and STS experts there. I was the engineering faculty member. This is really aimed at scholarship and research integrity and trying to do a better job for graduate students in that area. And that's primarily where most of our students went. Denver did a lot of work in developing resources around ethical data management, ecologies of data, to try to give resources to the faculty members to bring into their own courses, in some cases into their own research groups. They actually use some of what we've done to do more ethical interactions with their students in their own research groups. And the third version of this we did in collaboration with a colleague, Tricia Bertram-Gallant, who does really, really wonderful work in academic integrity. And what I like about Tricia's work is that it's just not the thou shalt not, but it's about focus on integrity and why we should try to be professionals with integrity and the difference it makes in our professional lives, and therefore you should start doing this now. So we tried to do an inspirational message as well as a know the rules and know how you get in trouble. So Tricia, if you're looking to do this kind of stuff, it's a great workshop. Because of the resources that we had and could engage her to do some consulting for us, she did this similar thing of a week-long workshop for us. She came back virtually at the end of summer to meet with the faculty. So, if you want to learn more about us, there's an early paper in 2003 about our workshops. There's some other work that we've done looking at the impact of the academic integrity workshop and what happens for students. And I think you already have this link to the resources. We were one of the exemplary programs chosen by NAE, so this is up on the NAE website. Thank you.
Thank you, Tom. And so as I mentioned, we're going to move to the macro level of change models. How do we change departments, programs, institutions, and the faculty that are in them? And so we're going to start with Jamie.
Hi, good morning, everyone. My name is Jamie Lester, and I'm an associate professor of higher education at George Mason University, which is just right over the bridge. So I had a nice trafficy drive in here this morning, but that's what happens when you live in DC. For about the last 15 years, I've been really invested in questions of organizational change in higher education. I come from a set of assumptions that change does, can, and happens every day within higher education institutions. I think it is an absolute myth when we hear these conversations around, higher education being this large ship that barely moves, and that change can take multiple decades. In fact, those of us who work in higher education institutions, and probably most, if not all of you in this room, have experienced, been engaged in some form of localized or even large-scale institutional change on your campuses. But knowing that we can change as a higher education institution doesn't mean that we know how to change it. How do we catalyze that change? Where does that change happen? How does it change? What are the strategies that we need to be invested? So I've been really, really invested in this question of how can we both promote, catalyze, and engage individuals in localized, non-planned, sort of emergent, or what I eventually called grassroots level change, and all the way to how do we then help individuals engage in strategic, planned change within higher education institutions. I'm going to talk today a little bit about some of the studies that I've been engaged in around interdisciplinary collaborations. And I'm going to argue in my very short talk today that one of the areas of consideration in terms of infusing ethics within engineering education is to engage in more interdisciplinary collaborations. And I'm going to do so based on sort of two studies that I've engaged in. There are more, but these are sort of the two that I think apply most to this conversation. And the first one was a study done with Adriana Kizar. She is an expert of organizational change at University of Southern California. And we looked at grassroots, or what we call non-positional leaders. So effectively, individuals who don't have a title, any formal responsibilities, any formal authority or power in an institution, who are able to create large-scale change. We focused on a variety of initiatives, but we certainly had several of our cases that also engaged in different forms of pedagogy reform. These groups primarily functioned as a team, which is also important to my argument. And that they were very intentional, not initially necessarily. In some cases, they came together with a passion or an interest, right? Like, we're really interested in ethics and engineering education. Oh, you're interested too. Okay, well, what can we do about it? What does that look like? And so in some cases, it was very emergent. They didn't necessarily have very specific strategies at the beginning, but developed those over time in order to really diffuse change throughout the institution. The other is an externally funded project. It's funded by Google, and we call it SPARK. It's a group with primarily computer scientists. It's working with the computer science department at Mason. I'm the only non-computer scientist in this particular team, and that's very important for my talk today. And the goal here is to create a new way of teaching introductory computer science. And so without going into too much detail, we're effectively have a self-paced with some sort of flipped classroom elements and a lot of evaluation work that's associated with that. What's important is that in most of the cases, almost all the cases of the grassroots study, as well as with the SPARK project, these are interdisciplinary teams. Now, how many of you have submitted or are submitting today an SFI use proposals? Yes, you feel my pain today. This is a model that actually will be in an SFI use proposal that I hope got submitted this morning. But I pull this up here, well, one, because it's very new and sort of summarizes my thinking and my work, but also I think it's very relevant to this conversation around how change within higher education institutions occur. You know, this is there's a lot here on this slide, and I'm not going to go into tons of detail about it. What I want to illustrate here is that change happens on multiple levels of a higher education institution, and that often it can and does occur within the local level. There's some language here around the particular design of this study, but effectively, the smallest circle there is reflective of individuals who who have a passion or an interest, who would undergo some form of training that would then help to expand that influence over time, ultimately moving from what we would think of as sort of innovators or change agents, right? Those people who want to spark change, all the way to the laggards. I won't say it's campus administration, but often it's campus administration. And so this effectively shows a model of organizational diffusion, how we go from one particular local level diffusing throughout the institution and what we would call sort of institutionalizing change. I think this particular model is important for this question around ethics in engineering education because way too often we find that the way to address pedagogy change within faculty, and much has been written about STEM faculty in particular, is around these sort of structures and policies, right? So create professional development opportunities. Think about tenure and promotion and reward structures. We think about, so that's within the policy realm. But rarely do we talk about what happens in terms of the relational pieces, right? So I go back to the panel previously in this conversation around how are we making meaning around what are the cultural and social norms within our individual disciplines, within our individual departments, and how is that then influencing how we're able to think about change and undergo change. And within this particular model is